Okay, so we are going to be graphing using a table of values. So we mentioned that this is a linear equation. So when we put in values for x and get y, we are going to be able to graph those on a graph, and they are going to make a line when we connect those dots. So we are going to be making a table of values to represent ordered pairs. So here's an example of kind of a detailed table of values where x is what we call our inputs and y is our outputs. So basically we're putting numbers in for x, putting it into the equation, and we're getting an answer for y. Here are the steps. I wrote down the steps for you guys to follow along. If you have a linear equation, you make a table of values, you pick any three x values, you substitute and solve for y, and you plot and graph your coordinate plane. So you could basically pick any values for x that you want. I'm going to recommend picking smaller numbers just so it fits onto our graph. I personally like to pick 1 negative, 1 positive, and 0, because those are pretty easy numbers to work with. As you get into more detail, if you're dealing with fractions, we can pick numbers that will make whole numbers rather than fractions, but that's getting ahead of ourselves a little bit. So I'm going to pick 3 numbers. I'm going to pick 1, I'm going to pick 0, I'm going to pick -1. And for these, you could pick these same numbers for every time that you were going to graph using a table of values. But again, that's personal preference, up to you. So what we need to do now is substitute these numbers in to our equation. So y equals, and then we have 2, and then we substitute for x plus 1. So I'm going to substitute 1 in for here. Now these are pretty easy problems as far as how we would calculate them. But again, if we're using our Desmos calculator to do this, we type it in once and we can just continue to switch out our input. So if we put our parentheses plus 1, and again, these you can do in your head, 2 times 1 is 2, plus 1 is 3. But if we're just going to do it this way, we could put we put a 1 in there and we get our output as 3. So we can do 3 there. So for the second one, we would do 2 times 0 plus 1. And again, checking it on the calculator, 2 times 0 is 0, plus 1 is 1. And then let's do a negative number here. So 2 times -1 plus 1. And we can back this out, put a -1 in there, and you can see that our answer is -1 for that one. So, I mean, we could pick any numbers we want, like I said. But the smaller the better, because then you'll be able to fit on a graph and you're not going off a graph, especially if a graph is provided. All right, so now essentially what we did is we came up with ordered pairs. Now we talked about ordered pairs and graph and plotting points where we have an x and a y value in an ordered pair. So essentially what we did here, here's our x, here's our y. So we have a 1, 3, we have a 0, 1, and we have a -1, -1. So we are going to put points onto this graph now using these points. So let's go ahead and make this a little bit bigger so you can see more detail. All right, so we are going to graph these points now onto this coordinate plane. So for 1, 3, I go 1 on my x, and then I go 3 on my y. So 1 for the x, 3 for the y, and I put a dot there. So that's that dot. Now I'm going to graph this dot here, 0 and 1. So 0 for my x, I don't go left or right, and then up 1 for my y. So there's another point on that graph. And then -1, -1, we would go to the left 1 and down 1, and we would put a point there. So you can see the 3 points now that are listed on our graph. Now all we have to do is draw a line through that, through those dots. So just draw a straight line, and I draw arrows to show that it goes on forever. So essentially what we're doing is any point that would fall on this line within this graph is a solution to that problem. All right, so this skill is, there's going to be different ways that we can actually graph and how we would go about doing it, but this way is by doing it with a table of values. Okay, so let's go ahead and do this one. Try it on your own if you want. Pause it, and then unpause it and see how you did. So I'm going to do this a little bit differently. I'm going to make a table of values. So I'm going to have my inputs and my outputs. All right, so I'm going to be using my calculator quite a bit on this. So as you get comfortable with this, I'm okay with you not writing out each thing that you do, but if there's a lot of mistakes, then I would encourage you to go back to writing out what you see so you can type it in your calculator correctly. I'm going to use a couple different numbers here. Maybe we'll use 2, I'll use 0 again, and I'll use -2. Like I said, I always like using one positive, one negative, and one 0, but really you can use all positive numbers, all negative numbers. That part doesn't matter. All right, so here's my equation now. I have a -3, and I'm going to write the equation over here. So -3, we're going to substitute our inputs on x plus 2. All right, so I'm going to bring up my calculator, and I'm coming up with 3 inputs for that. So let's go ahead and type that into our calculator. So we have my -3, I do my parentheses, plus 2, and now I'm going to put in my x values. So for the first one, I'm putting in a 2. I get -4 as my answer. The second one, I only have to back out these inputs. Let's put 0 in. -3 times 0 is 0 plus 2. That gives us 2. And then finally, we're going to do -2. So -3 times -2 is positive 6 plus 2 gives us 8. So again, I'm picking any 3 numbers that you want. So once I do that, now I have to just plot these onto my graph. So for my x value, for my first one, I have 2, -4. So I go 2, and then down 4, 1, 2, 3, 4, and I put that dot in there. For my second value, I have 0, 2, so I'm not going anywhere, but I go up 2. That would be my second point. For my third point, -2, 8, so -2, and we go up 8. 1, 2, 3, 4, 5, 6, 7, 8, and I put a dot there. All right, so now you can see that they're going in a line. So I can draw a line through those 3 dots to indicate the equation of that line. All right, so that's pretty much all there is to it. Now I'm going to do one more sample problem. And this is what happens if, let's say it's not in that slope-intercept form. So let's say I have a standard form problem. 2x plus, I don't know, let's say y equals, let's say 6. All right, so now I'm going to graph this using a table of values as well. Now, my inputs and outputs are now on the same side, so we can do what we did the other day and put it in function form or slope-intercept form, what we call it. So we do that 2-step problem. In this case, it's a 1-step problem. Subtract 2x from both sides, and then we're going to write it out. Y equals, let's write that x value first, -2x plus 6. All right, we don't have to divide anything by y because it's already there. So now I would make a table of values. So I'm going to use this equation now to do my table of values. So let's pick 3 points. I'm going to go back to 1, 0, and -1 for that. All right, so let's bring up the calculator again. And let's type in this part of the equation. So -2, parentheses, that's going to be my input, plus 6. So I'm using 3 different ones. So let's type in and see what we get. For 1, we get 4 as our output. For 0, we get 6 as our output. And for -1, we get 8 as our output. All right, so once we come up with our table of values, then we can graph. Obviously, I don't have an order or a coordinate plane, so I'm just going to do my own. Let's draw our y and our x-axis here. Remember, this is our x-axis, this is our y-axis. So I'm going to make some points on this graph. So for when x equals 1, y equals 4. So when x equals 1, y equals 4. 1, 2, 3, 4. I'm going to put a dot in that space. When x equals 0, y equals 6. So for not going left or right, I have to go up to 6. 1, 2, 3, 4, 5, 6. I put a dot right there. And when x equals -1, y equals 8. So here's -1, y equals 8. So that was 6. I go up 2 more. That would be my 8. So you can see they are in a line, and we connect those dots. Obviously, it's not a perfectly straight line because there's human error with how I am inputting those. So that is not as important if it's exactly on it. I'm not going to worry about that, but you can correct it if you want. So the idea is that you get that I can see a pattern of those lines and that you can draw a line through them. So that's how you would graph it if it was in standard form and they didn't give you a graph to set it up.